Hello, everybody, and welcome to our lesson 5.1 in our textbook on page 263. And so we're starting chapter 5, and the first lesson is on the polygon angle sum theorem. And what a polygon is a closed many-sided figure. And the word poly means many. So the first closed many-sided figure we know is a triangle. So a triangle has 3 sides and it's closed, so that's a polygon, 3-sided figure. The next one is if you have 4 sides, 1, 2, 3, 4, that's closed, it has 4 sides, that's called a quadrilateral, and then so on and so forth, 5 sides, and it can be shaped any way you want. It doesn't have to be a square or a rectangle. It can be lopsided. As long as it's closed, it has no indentation, all the corners face outward, and it's closed and it has sides. It can't be a circle or anything like that. So poly means many and gon means sides. And so poly-angled sum theorem, remember in the triangles, we figured out that the sum of all the interior angles of a triangle is 180 degrees. Well, we are going to figure out how much is it in a 4-sided figure, in a 5-sided figure, in a 6-sided figure. They all have certain sums they add up to, the interior angles. And so you're going to learn that. And I want you to also look at, so we're finding, let's underline our objectives, the sum of the measures of the interior angles. So angles, it's the angles we're talking about of a polygon. And also we're going to find the sum of the measures of the exterior angles. So what's the difference? Interior angles are on the inside of the shape, like these are interior, exterior on the outside of the shape. And how are they created? If you extend one side, it creates an exterior angle. So all of these angles are exterior. So if you have a 4-sided figure, you're going to have 4 exterior angles, 2, 3, 4, okay? If you have a triangle, you're going to have 3 exterior angles. Exterior, interior. Okay, so make sure you look at that when you read your questions, that you understand, are we talking about exterior or interior? And let's look here. We have a little formula which is really not hard to understand. I'll make it easier for you. It's called the polygon angle sum theorem. The sum, let's read this here. Essential understanding. By the way, I want to reiterate to you that make sure you listen to the audio. I should write that here because in case you're not, must listen to audio. Because I have noticed that if you listen to the audio and you rewind or stop when you're not sure, when you're confused, and rewind and listen to it again, maybe, I think your understanding is going to be a lot better than just mindlessly taking down notes without ever thinking about what it is, maybe doing something else on the side or watching TV or listening to music. No. You're not going to understand, and then you're not going to be able to recall the information or understand what's going on. So please listen to the audio. Please stop the audio and rewind if you're not sure, and make your notes yours. This is, take ownership of your notes so that you understand them and understand the process, how we solve problems. Okay. So the sum, meaning you're adding, sum means add, of the interior angle measure of a polygon depends on the number of sides the polygon has. Important. This is a big thing. You need to know how many sides. Yeah, that's how many angles, what the sum of the angles is. The more sides, the bigger the sum. Okay, so let's look at this theorem here. The sum of the measures of the interior angles. What is an N-Gon? N means simply, an N-Gon is any closed figure. So the word N-Gon just means any closed figure, where N is the number of sides. This is important. N is the number of sides. Okay, so N-Gon is a closed figure and N means how many sides it has. So if N is, let's say 5, you will see 5 gon. So for example, a 5 gon has 5 sides. Okay, so this little formula here says that to find sum, this is all important, so make sure you write this and look at it. Subtract 2 from number of sides. And then multiply by 180. And that's what this little formula says. And I'm just writing it down with words, yeah? Sum of angles. Interior angles. Okay, all right, let's look at number 1. What is the sum of the, so when you read the question, make sure you understand, are we talking about interior angles? And because later on, we're going to also have problems with exterior angles. So you need to read correctly. What is the sum of the interior angle measures of a 17 gon? So that we have 17 sides. We can't even draw that. That looks a lot of sides, right? In other words, n is 17. That's all we need here. So 17, subtract 2 is 15. Subtract 2 from number of sides, 17 sides, and then multiply by 180. So 15, use a calculator, try it yourself. 15 times 180, pause the video and do it, because you're going to have to do it later and you'll be confused. How do you do it? 15 times 180. It's always the same, by the way. Always subtract 2 from the sides, multiply by 180. So the sum of all the interior angles is 2700 degrees. The sum of all interior angles of a 17-sided figure is 2700 degrees. Okay. Okay, next page. And we'll do the top here. Okay, now this is a little bit backwards. We have to find the sides. We know the sum, but we need to find the sides. Okay, so let's read the question. The sum of the, again, interior angle measures of a polygon. Well, we don't know how many sides is 1980, so 1980 degrees. How can you find the number of sides? So we need to find the number of sides, which is n. Yeah, n is the number of sides. What's n? So remember the little formula in the beginning, it had n minus 2 times 180. That was on our first page, right here. This little formula, which I wrote it in words here, subtract 2 from the number of sides, multiply by 180. Well, let's use the formula and we're going to work backwards. We know that the sum is 1980, so my formula has to equal 1980. Yeah, so write equation, work backwards. Now this right here is one question that you'll see on the homework and you'll say, well, how do I do it? Look for a question that matches the way they're asking the question on the homework and look at it, write equation. Now the sum is that. Now you're going to distribute. So you're multiplying 180 times n is 180n. 180 times -2 is minus 360. Add 360. Remember, we're looking for n. Add 360. 180n is not 2,340. I'm going to bring that over here. I'm running out of space. This is what you do when you run out of space. You rewrite somewhere else, make an arrow. Divide by 180. And put this in your calculator. It's a division problem. I think n is 13. Check it out. So n is the number of sides. So how can you find the number of sides? I'll say work backwards. It has 13 sides. Let's do one more. No, that they're not the same. Here they, nope. This one is easy. Subtract 2, multiply by 180. They're only showing us one example here. I'm not really happy with that because this is kind of hard. So I was hoping we have more examples. So maybe you should make sure you write this correctly and put a big arrow. Look it over, study. The main thing is you read your question. They're giving you the sum, so you're not finding the sum. You need to find the number of sides, which is n in our formula here. Okay, so this is very, very intricate. So look at it again and see if you can make sense out of it. Okay, let's move down here. In the middle of the page, it's talking about words. An equilateral polygon means lateral sides. So all sides are equal. Notice the little tick marks tell you all sides are equal. Equiangular polygon. Angular means angles. So all angles are equal. So notice these are angles, right? And they're all equal because they have the same amount of bows. And then it's regular. Regular means all sides and angles are equal. This is the word you need to look for. Look for this word in your questions. All sides and angles are equal. Oops. Okay, regular polygons are the ones that are easiest to work with because you can just divide by how many sides there are to find a side length. Or you divide, so I'm going to put the clue here, it's called divide. Okay, divide to find the side length, divide to find the angle measure. So when it's regular, it's super easy. None of these really work unless it's this one. But this is really the best, okay? So this formula here is confusing to you. I can imagine the measure of each interior angle of a regular N-Gon. Notice regular many-sided figure. You find the sum. This is what's happening here. Find the sum first, and then you divide by how many sides. And I'll write that out here again. So find first step, find sum. Second step, divide answer. Divide answer by number of sides. So this is your sum right here, and then this is dividing. So notice it only works if you have a regular. So this is why this word is so important. If it's not regular, you cannot find the measure of each interior angle. Yeah, must be regular. Regular, okay? So let's see if we can do this down here using the polygon angle sum theorem. What is the measure of each interior angle in a regular nonagon, which is a 9-sided figure? How does the word regular help you answer the question? Find sum, divide by 9. You can only do it if it's regular. And remember that up here, the word regular. Whoa, this is what we're looking at, regular polygon. Yeah, all sides and angles are equal. If all the angles are equal and you know the sum, you divide by how many sides there are and you got each angle, because there's exactly how many angles as there are sides. If there's 9 sides, you got 9 angles. Okay, so first let's find the sum. 9-sided figure, take away 2 is 7, multiplied by 180. It's always the same, guys. It never changes. Okay, don't overthink it. So 7 times 180 is 1260 degrees. This is the sum of all the interior angles in a 9-sided figure. Well, we want 1. Yeah, each means find 1. So that means I have to divide my answer by 9. 1260 divided by 9. I still got it in the calculator. Don't retype, just go, keep going. It's 140 degrees for each angle. You see? Okay. All right, well, we're moving on, guys. You can always stop the video. How about this? Watch the video and then watch it or stop it and take notes. So you don't constantly write and listen. That's sometimes hard too. You know, it takes longer, yes, but you might get better quiz results. Yeah, you might answer the quiz questions right and your grade goes up. You answer the quiz questions wrong and your grade goes down. You all understand that. So it's really important to make your learning your own and not have it just because the teacher or mom or dad say so. Okay, next page is 265. Am I on this one? Yeah, 265. Let's look at these pictures. These are all polygons. This is actually a coin that has sides, but I'm not going to do this question because I was too lazy to count the sides. Maybe you can. Maybe we can do it. It actually has sides. Let's do it. 1. So notice when I count the number of sides, this is some queen, maybe from England, Queen Elizabeth. Huh, who knows? So when I count the sides, I start at a certain point, but I have to remember that point. So I'm not going to start willy-nilly somewhere. I'll make it the top so that I remember, like, I'm going to go right to here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 sides, right? It's called a 12-gon. 12 sides. Yeah, do you see? So n is the number of sides, 12, right? And so we want find the measure of one interior angle in each regular. Remember, regular, super important. If it's not regular, you cannot do it. So these are the words I'm looking for, polygon. So n is 12. First, find the sum. Second, divide by number of sides. Sum 12 minus 2 is 10. 10 times 180 is 1800. I just add a 0 here. Divide by number of sides, 12. (150 degrees). So in other words, each angle here is 150 degrees, each one of them. Do you see where there's a big angle here, right? Almost a straight line. That's why the number is so big. These are all angles. Anyways, for each angle. It's a pretty picture, huh? I'm just showing you what that means. Now I did this one, but I didn't do the coin, but I did this one, so might as well do it. This is a, oh, I don't even know. 5 sides? 1, 2, 3, 4, 5, 6 sides. It's called a hexagon. You know what? I'm not sure if this is a side or am I doing this wrong? Let's just count it as a side. Make it n is 6, right? So again, find the sum. 6 minus 2, 4. 4 times 180. So for any 6-sided figure, the sum is always 720 degrees. And then you have to divide your answer by 6. Because you want 1. So it's 120 degrees for one angle. You know what I just noticed? This is not regular. The way I drew it, It might not be a hexagon. It might, I thought it was a pentagon, which is a 5-sided figure. It might be that I misconstrued. Yeah, you know what? This is how it works. This. It's a pentagon. 5 sides. So I'm going to erase that. And you know what? When you make a mistake, you're like, oh, a mistake. Sometimes it's so easy. Watch what we're going to do. Pentagon. And we only need to change a few numbers. So we're only changing this number. So you don't have to erase everything. And then, of course, that's not right. That's going to be 3. And then 3 times 180 is 560, I think. 540. 540. And then we divide by 5. And that's it. That's all we have to do. 540 divided by 5, 108. So 108, each angle here is 108 degrees. You see? Each one of these. They're all the same because it's regular. And so there you go. That's how you find one angle if it's a regular polygon. The steps are right here. Pause the video, halt it, look at it again. Now, this is not a regular. Problem 3 is not. You see how all the angles are different? So this is not regular. So when it's not regular, you have to figure out the sum and then look what's missing. We're missing this angle here, right? And that's probably what they're asking. What is measure angle G in quadrilateral 4-sided figure EFGH? So first find sum. Most likely always you have to find the sum and then add these 3. And then subtract from sum. So it's kind of like with a triangle, you know it's 180, you know 2 angles, you add them and subtract your answer from 180. But now we have 4 angles. What is the sum of the measures of the angles in a quadrilateral? So n minus 2 times 180. So n is 4 sides, right? 1, 2, 3, 4 sides. Then you do 4 minus 2, and then 2 times 180. It's always 360 degrees. Any 4-sided figure, the sum is 360 degrees. So now we add 120. So we're done with the sum. It's 360 degrees. Now we're adding all 3 angles, 120, 85, 53. And I believe that sum is 102, no, what is it? 258. 258 degrees, and now we subtract, so that's this 258. And now we subtract your answer from sum, which is 360. So 360 minus 258. 102 degrees. The missing angle it's called angle G, is 102 degrees. Yeah. If you add all 4, sum has to be 360. So 360 degrees is sum for any four-sided figure. And this right here, I want you to highlight because you're going to maybe be asked that in my questioning when you show me your homework. For a triangle, it's 180. And for a quadrilateral, 360. Okay, we're skipping this. And then we're going on to the next page. Do we have any? Oh yeah, now we're talking about exterior angles. So remember, in the beginning of the lesson, I promised you exterior versus interior. So you can draw exterior angles at any vertex of a polygon. The figures below show that the sum, this is super important. This is so easy, watch. The sum of the measures of all the exterior angles is always 360. It's never changes. It's no matter how many sides, the sum is always 360 degrees. So the exterior angles are when you continue a side and you form an outside angle, outside. Yeah, you have to extend a side. When you have four sides, you got four exterior angles. And the sum is always 360 degrees. So let's look at this theorem here. The sum of the measures of the exterior angles of any closed many-sided figure. That's what a polygon is. Is always 360 degrees. Yeah, so you have a picture, all these exterior angles, if you add them up, for some reason, they always add up to 360. So I'm gonna write that here. So you have nothing to look at but what we're writing, sum of all exterior angles of any polygon, no matter how many sides, is always 360 degrees. So this is also important. So make sure you highlight that or use a different color marker to box it so you can find it. So you're not sitting there going, oh, I don't remember. Well, that's what notes are for. You can read again and recall the message, okay? So exterior angle measures. Here we have a question, number 7. Find the measure of one. When they say of n, it means one. Of one exterior angle, again, exterior versus interior of each. It has to be regular, by the way. If it's not regular, they're all going to be different, but the sum is always 360. So sum is 360 degrees, and we got 36 exterior angles because we have 36 sides means 36 exterior angles. So therefore, we divide. It's a division problem. 360 divided by 36, because you can, when it's regular, each one is the same measure, you just divide, and that's 10 degrees. So each angle, each exterior angle is 10 degrees. With 100 gone, it means 100 sides means we have 100 exterior angles. And they're all the same measure because it's regular. So we have the sum, it's always 360 divided by how many angles there are. And there you have it, you have 3.6 degrees. Use your calculator, 360 divided by 100. Okay, next page is homework and you're on page 267. So we're starting with number 9. Make sure you circle them all. What is the sum of the interior angle measures of an 11-sided figure? Okay, 11 gone, right? Remember the formula, n minus 2 times 180. That's what you do. Look at your examples. Number 10, what is the sum of the measures of an exterior angle of a 15-sided figure? Yeah, what is the sum of the exterior? I just talked about it. Look at your notes. Number 11, this is super easy. Don't overthink it. Number 11, find the measures of one interior angle and one exterior angle of a regular decagon. A decagon has 12 sides. If you ever come upon a question and you don't know what a decagon is, you can Google it. How many sides does a decagon have? I think it's 12. Okay, so that's that. Look for examples. This one is a little tricky. Can you draw an equiangular polygon? Look up definition on first page. Or was it second page? I'm just going to say look up definition because it's in there in the lesson. You just have to flip your pages sometime, okay? That is not, so can you draw an equiangular polygon that is not equilateral? Equiangular means equal angles. That is not equilateral, equal sides. So this is your drawing. Oh, your drawing experiment. And then it says explain. Maybe you can, maybe you can't. Okay, so let's see how you're doing on that. And then I have question. I do have 13, which is hard. So this one asks about which angles are the exterior angles for angle 1. Angle 1 is interior. Which of these are exterior angles? What do you know about their measures? So you got to think about, so first you name them and then you can say, well, I know this about them, or I have no idea. And then there's an error. Your friend says that she measured an interior angle of a regular polygon as 130. Explain why this result is impossible. Okay, then you're going to use your equation to find the number of sides. Look up the example. I gave you one example in the notes. So you're doing 15 and 16. And then the one that you might have a hard time with or not is number 22. Okay, so these are the questions. Good luck to you. Bye-bye.